In this project, we are going to be exploring raster data and the raster data model. You've been using vector data up until this point. Raster data is the second major type of data model that is used. And you're already familiar with raster data, even if you're not that aware of it. It's used in photography, particularly, where images like JPEGs, bitmaps, PNGs, TIFFs, they're all files that store raster data. And what raster data is composed of is tiny little squares, or sometimes other shapes as well, called pixels, that each have one particular value assigned to them. Now, they could, if they are complicated rasters, have more data packed within them. But in a typical raster, we're looking at, for example, imagery data that will have a pixel that will have some sort of marker for what the color is going to be, that will usually be composed of three what are called color bands. Pixels can be used though to store a lot more than just image related data. You can collect all sorts of satellite based data using different parts of the visual and non-visual spectrum. You can also put other types of data in pixels that are numeric and might represent some sort of classification system. There's really a bunch of stuff that can be done with the raster data model. The pixel size is going to determine the spatial resolution of the raster. If we're looking at satellite imagery, for example, and you have resolution that is 1 by 1 meter in size, you're going to have significantly greater accuracy, obviously, than you would if the rasters are 100 meters by 100 meters. Obviously, the greater the resolution you have, the greater the file size you have. This is why when you take photographs with cameras that have very high resolution, the size of the JPEGs that are created by them, or the other files that are created from them, are really large and unruly. There are lots of advantages and disadvantages to the raster data model. The advantage is that it does a really good job of symbolizing continuous data. And the map you see in the lower left-hand side is one that shows temperatures. And temperatures are obviously something that are continuous across the surface of, in this case, the contiguous United States. And using raster data is a really good way to show something like this that is continuous. If, however, you have very discrete data, and the map on the right-hand side just shows some data for different cities, that wouldn't be a good use of the raster data model. That's much better for vector data model, and of course in this case, points and graduated circles. Raster data models are very simple to build and easy to display as well. The problems with them though are that number one, they can get really large and really difficult to use, and they can start crashing systems if you don't find ways to reduce their size. And that usually means you're getting rid of some of the resolution. And then also low resolution rasters in many applications aren't particularly attractive. Say, for example, you have some sort of satellite imagery that shows roads on it, and the roads are being shown as pixels at a resolution of 100 meters by 100 meters. Number one, you might not even pick up the roads in the raster data, and then if you do display them, they're going to be these little blocky things that just don't look particularly good. Raster data comes from a bunch of different places. Already in this class, you have used aerial photography raster data. Each of the study area maps are made of aerial photography that is, of course, rasterized and then has been manipulated and georeferenced. And then there's all sorts of satellite imagery data as well. On the left-hand side, you can see what's called a height map, which you will be using in the project. This is a map that just shows elevation using black and white, essentially. Higher elevations in this particular image are represented by lighter colors. The picture in the middle is what's called a false color map that uses infrared radiation that is sensed by satellites as well as visible light to produce a map that helps us to disaggregate different types of vegetation in an area. It's very commonly used especially in vegetation studies. And then the map on the right-hand side is one that is based on raster analysis, in which satellite imagery has been taken and analyzed, and through various raster forms of analysis, including probably raster algebra and the application of algorithms, there has been a land classification system that has been attached to this raster data. So there are all sorts of different types of raster analysis out there, and this we're just going to touch on them in this course. Some of the most important ones, and the ones in particular that you'll come into at least some contact with, will be first taking raster data and then using it to produce vectors. You can make contours, for example, or you can make vegetation polygons out of raster data. You'll also make a hillshade, which is shown in the upper image here, which takes raster height data and then applies an algorithm to it to shade it so that we can really see the contours of things well. You'll also, you could potentially in this project do some slope or aspect analysis. The image on the lower right-hand side shows some mountains with slope analysis that has been done to analyze where there's greater avalanche hazard in an area. And then on the lower left-hand side is watershed analysis, which shows the direction that water will be flowing and where streams are likely to appear. They're shown as little blue vector lines in this raster data. In addition to this, there are just a ton of other different things you can do with rasters. On the most basic level, you can do things like clipping rasters. Generally, you need to have a vector, like a vector box that you can then use to clip, to either take data away or to select just the area that you want. You can also mosaic rasters together. That's shown on the bottom, where you take two different rasters and you blend them together. Then there's lots of analysis that you can do using the numbers that are assigned to pixels to apply different algorithms or algebraic formulas to them. And this can be used then to classify data, and it can also be used to smooth data as well. We are not going to get into very much of this at all. This is better left for a more advanced GIS class, but just know that there are plenty of cool raster things that can be done out there.